another Daishinfinity video. In this video, we're going to prove the derivative of the hyperbolic of tangent of x. It states that the derivative of the hyperbolic of tangent of x is equal to the secant hyperbolic squared of x. So in this video, I am going to prove you guys with using the differential quotient by the limit. Before we dive right in, we have to define what the definition of a derivative is. The definition of a normal derivative of a given function f of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. Now our f of x is equal to our tangent hyperbolic of x, which is also equal to the sinh of x, so the hyperbolic sine over the hyperbolic cosine of x. So we can just plug this whole thing in. But before we plug this whole thing in, we know that sinh of x can be represented with only exponential function e of x by Euler's formula. It states that sinh of x is equal to e to the x minus e to the negative x divided by 2, and cosh of x is equal to the e to the x plus e to the negative x over 2. So if we have the tangent of x, which is sinh of x over cosh of x, it's equal to e to the x minus e to the negative x over 2 over e to the x plus e to the negative x over 2. So the 2's will cancel out, and then we'll have e to the x minus e to the negative x over e to the x plus e to the negative x. So this is our formula for the tangent hyperbolic of x. Now since we have this, we can use the limit definition to plug in the e to the x inside. So we have to plug in the x plus h in the beginning. And I'm just going to distribute it how it is. So it will be like this minus the whole thing and the whole thing over h. Now what we are going to do is we are going to try and make this one big fraction. So since it is going to be a big fraction, I'm just going to let the limit be a capital L, and then I'm going to multiply both sides by this denominator and this denominator, such that we can cross multiply and then get the same result here. So we'll just get e to the x plus h minus e to the negative x minus h times e to the x plus e to the negative x minus, now another parenthesis, e to the x minus e to the negative x times e to the x plus h plus e to the negative x negative h. I'm sorry for the plus, it's actually negative. I'm sure I have it right. Yes, I should have the negative over there. Then we have everything divided by h times e to the x plus e to the negative x times e to the x plus h plus e to the negative x minus h. Now since we have all of this, we can distribute the parentheses here and here so that we will get a simple result. So it's going to be the limit as h approaches 0 of e to the x plus h times e to the x equaling e to the 2x plus h. Then we have e to the x plus h times e to the negative x, which will equal e to the h. Then we have minus e to the negative x minus h times e to the x, so the minus x and the x will cancel out. So it will equal to e to the negative h. Then we have minus e to the negative x negative h times e to the negative x, so minus e to the negative 2x minus h. So then we are done with the first part. Then we are going to go on and do the second part, which is going to be minus parentheses e to the x times e to the x plus h will be e to the 2x plus h. Then e to the x times e to the negative x minus h is going to be e to the negative h. Then we have minus e to the negative x times e to the x plus h, so e to the h. Then we have minus e to the negative x times e to the negative x minus h, so e to the negative 2x minus h. Everything in parentheses so that we don't have any issues. Then we can have all of this as a denominator, which we will change in a moment. And this is the green part. Now, since we have two of them, we have to distribute the minus sign onto those components. Then we have the limit as h approaches 0 of e to the 2x plus h plus e to the h minus e to the negative h minus e to the negative 2x plus h, negative h, negative e to the 2x plus h, negative e to the negative h plus e to the h plus e to the negative 2x minus h. Which means that this and this one is the same, but it's just the opposite of it, so we can cancel it out. Then we have negative, we have e to the 2x plus h minus e to the 2x plus h, so these are also going to cancel out. And then we can put those components together, and we forgot to put in the denominator, so we will just finish the denominator, and then we will continue with our second part, which states that we can just write the e to the h 2 times, because we have a 2 times, and then we have 2 times the negative e to the negative h, and the everything over h times e to the x plus e to the negative x times e to the x plus h plus e to the negative x minus h. So we can put the 2 out of it, out of the limit, because it's a constant. And we can also put this whole parentheses out of the limit because it's independent of h. So we have 2 e to the x plus e to the negative x times the limit. Now we can write the whole limit. Definition, h approaches 0 of e to the h minus e to the negative h over h. And I'm just going to write it this way because I have something to do with it. The reason why I did it this way is because we have a limit definition, that a limit as as x approaches a of f of x g of x is equal to the limit as x approaches a of f of x times the limit as x approaches a of g of x. So it will be f of a g of a. So this is going to be f of x, and this is going to be g of x, and then we can just put the limits separately. The reason why I'm going to do this is because there's a specific thing I want to do called the L'Hopital's rule for the first f of x. So we have this times the limit as h approaches 0 of e to the h minus e to the negative h over h times the limit as h approaches 0 of 1 over e to the x plus h plus e to the negative x negative h. The reason why I did it is because when we let h approach 0 here, it's going to be a 0 over 0 kind of thing, because e to the 0 is 1, so this is equal to 1, and e to the negative 0 is equal to 1, so 1 minus 1 is 0, and 0 would be here, so 0 over 0 situation. So that's why we can use the L'Hopital's formula, because for L'Hopital we can use the limit, the derivative on both sides, and apply them in order to get a better answer. But as for the other fraction, we can just get the answer because when we let h approach 0 here and here, we just have 1 over x e to the x plus e to the negative h, and we can ignore the limit because it's independent of h after all. And since this and this is just equal, we can just put this outside the limit and just have this 2 times. And then we have the limit as h approaches 0 of e to the h minus e to the negative h over h. And now we can use the L'Hopital's rule. So we let everything make the derivative with respect to h. So if we look at the fraction here, then we would have the limit as h approaches 0 of the derivative of e to the h, which is e to the h, respect to h, negative e to the negative h. The negative will go to the front, so we have positive e to the h, negative h, sorry, all over 1. Because the derivative of h with respect to h is equal to 1. Now, if we let it equal to 0, then we have e to the 0, so 1, and e to the negative 0, which is equal to e to the 0, also equal to 1. So 1 plus 1 is equal to 2. So we have 2 times 2 divided by, so 4 divided by e to the x plus e to the negative x over 2. Or in other words, 2 over e to the x plus e to the negative x over 2. 2 over e to the x plus e to the negative x times 2 over e to the x plus e to the negative x. Now, why did I do this way? It is because we can now write it as 2 over e to the x plus e to the negative x, the whole thing squared. But what is 2 over e to the x plus e to the negative x? Now, we know that cosh of x has its formula e to the x plus e to the negative x over 2. So if we let everything go, take the reciprocal of it, it will mean that we will have 1 over cosh, which is equal to the secant of hyperbolic x, and that is equal to 2 over e to the x plus e to the negative x. And this is just equal to this. That's why we can plug in the secant hyperbolic, and we get secant hyperbolic squared x. And that's why I proved to you right now that the derivative of the hyperbolic of tangent of x is equal to the secant hyperbolic of x squared. Thank you guys for watching this video. It was a very long video. If you guys have any questions, write them down in the comments, and subscribe to my channel. I hope you like this video, and we will see us in the next Daishinfinity video. See you.